have been many changes in fighter aircraft over the past 70 years, but fighter pilots remain the most elite element of modern armed forces. This video ordnance program examines the remarkable changes in men and machines engaged in the dangerous business of aerial combat. There is a certain nostalgia associated with the simple biplane fighters of World War I. Brave, chivalrous pilots took to the sky to wage man-to-man combat, free from the horrors of the trench war below them. They were knights of the air. The reality of World War I aerial combat was hardly so glamorous. The early fighter pilots were woefully unprotected. An efficient parachute had not yet been invented, so there were no means to escape a burning aircraft. It took remarkable talents to fly these early planes and to stay alive in the deadly arena of air combat. Maneuverability was a key to victory in early air combat. The Fokker DR-1 triplane, seen here, was a good example. The Fokker was a plane of aces, flown by Germany's top pilots like the Red Baron, Manfred von Richthofen. Its designers gave it short, stubby wings to make it more maneuverable. But this came at a cost. The Fokker was powered by a radial engine which spun, along with the propeller, to keep it cool. These spinning forces, called torque, made the aircraft difficult to control. In the hands of an experienced pilot, it was unbeatable. But many pilots found it was more than they could handle. In the half-century since World War I, fighters became larger, faster, but less agile. In the past 10 years, new technologies have made high-speed maneuver possible again. New fighter designs are remarkably maneuverable. Like the Fokker triplane, their designs are aerodynamically unstable, but unlike the Fokker, they are safe and easy to fly. This is made possible by a new flight control system called fly-by-wire. A computer controls all flight surfaces. A pilot cannot possibly make all the minute adjustments necessary to keep the plane stable during high-speed maneuvers using conventional controls. But the computer can be programmed to adjust several control surfaces simultaneously to give the pilot the desired maneuver without the airplane going out of control and crashing. With a World War I biplane, there was a constant contest between the pilot and the plane just to keep it in the air. In a modern jet fighter, the machine responds to the flick of a wrist. The traditional weapon of the fighter plane has been the machine gun. World War I fighters had their machine guns mounted on the fuselage because the wings were too fragile. The trick to this arrangement was to avoid shooting off the propeller blade. The critical innovation was a device called an interrupter gear. This device was linked from the engine to the machine guns. When the propeller was clear, the guns could fire. But when the propeller blade neared the top of its cycle, the gear prevented the machine guns from firing. By the Second World War, fighters were mostly constructed of aluminum. Their wings were much more rugged than those of the old biplanes. World War II fighters had 4 to 8 heavy machine guns, giving them much more firepower than the fighters of World War I. Over the past few decades, missiles have gradually replaced guns as the weapons of choice. The first practical dogfighting missiles used infrared guidance. A small seeker in the nose senses the heat radiated by the enemy airplane. This is what a fighter would look like to the human eye. but to the missile, only the infrared energy is seen. Early infrared missiles were not very sensitive and could only detect the hot exhaust gas of another jet. So a jet had to maneuver behind an opponent to fire the missile. But newer infrared-guided missiles, like the AIM-9L Sidewinder, use an improved type of seeker which can detect smaller amounts of infrared energy. Heat builds up on the forward surfaces of a jet during high-speed flight due to friction with the air. The missile can detect this heat, allowing it to be fired from head-on. This makes the infrared missile much more deadly. Infrared energy is absorbed in the atmosphere, so for long-range dogfighting, radar guidance is necessary. The basic type of radar guidance is called semi-active homing. The plane uses its radar to paint the enemy airplane. Some of the radiation bounces back off the enemy aircraft and returns to the fighter plane. The radar-guided missile is able to sense this reflected energy, but the pilot must keep his radar pointed at the enemy airplane until the missile hits. The infrared missile is the short-range missile. The radar missile is for long-range engagements.
The AIM-7 missile, our radar missile that we carry right now, the Sparrow is primarily designed to get a first shot opportunity, a longer range shot, kill the threat before he even knows that you're out there.
But the fighter's gun has not disappeared. The modern fighter is typically armed with a single 20mm Gatling gun. A World War I fighter had 2 machine guns and could fire about 800 rounds per minute. By World War II, fighters had 6 or 8 guns and could fire at the rate of 3,000 rounds per minute. The modern jet fighter's single gun fires at the remarkable rate of 6,000 rounds a minute, or a sizzling 100 bullets every second. The gun still remains an important weapon on fighter planes, but no longer the most important.
Well, I don't think we really de-emphasize one or the other. Obviously, you would like to use the missile. I think what they found in Vietnam is about 80% of the kills occurred with the missile. Same thing was pretty much true in the Israeli experience in the Middle East, pretty much about 80%, plus or minus a little bit. So the gun is still a valid weapon. You still have to know how to employ it. You still may be put in that position. Your weapons may not work. You may shoot all the weapons, so you may need that. So we put an emphasis on both of them. Obviously, the missile is a little more difficult to employ because what all is involved with tracking the target, finding him, and getting in parameters and those sorts of considerations. The gun is strictly flying the airplane. Now, I'm not saying that's not difficult to do at all, but you're maneuvering off an aircraft that you can see. You're in a lot closer to him before you take the shot.
For nearly 50 years, the dogfight was a close-range duel. The machine gun was only effective to a range of a few thousand feet, so the dogfight took place within human eyesight. With the advent of radars and missiles in the 1960s, dogfights could take place beyond human eyesight, at ranges over 35 miles away. This has fundamentally altered the nature of air combat. Modern interceptors, like the Tornado ADV or the F-15 Eagle, carry 3 distinct types of dogfighting weapons.
The F-15 carries the AIM-7 Sparrow missile, which is our radar missile, or BVR, longer range look missile. Medium range is what it's designed for. We also carry the AIM-9 Sidewinder missile. Again, that's a more short range missile. And we carry a 20mm gun.
In the jargon of fighter pilots, these weapons control 3 envelopes. The gun controls a shallow area up to half a mile from the airplane. The short-range heat-seeking missile, like the AIM-9 Sidewinder, controls an envelope about 10 miles in front of the airplane. The long-range envelope is covered by the radar missile, like the AIM-7 Sparrow. An enemy plane has to pass through 2 deadly missile envelopes before a gun duel can take place. Tally-ho is the battle cry when the enemy is first spotted. This is the first stage of a dogfight. In today's jargon, it's also called the initial merge, or initial point of attack. In the modern dogfight, This is when the opposing fighters become aware of one another on their radar. The fighter pilot who first identifies the opponent has a critical advantage. This is what a fighter pilot sees on his radar screen.
The important thing in using the radar is obviously to control the initial point of attack, and that's what the radar is designed to allow the F-15 pilot to do, to control that initial merge or the initial point of attack by shooting first or getting to a position where he can employ ordnance first, and that's what runs the war.
For this reason, modern fighter planes are designed around their high-performance radars. The airplane with a better radar identifies the enemy sooner and gets off the crucial first shots. Superior technology and a superior radar can give a pilot a critical edge in a dogfight.
The reason the F-15 is so big is primarily because of the emphasis that was placed on the radar capabilities in order, again, as I said earlier, to get that first shot opportunity.
But at this stage of the dogfight, the enemy plane is just a little electronic blip on the radar scope. How can a pilot be sure that little blip is hostile? Airborne command posts like the E-3 AWACS can help. The AWACS radar plane monitors the skies for hundreds of miles, right from the time that the enemy fighters take off up to the first point of contact. Without the help of the AWACS, modern fighters are fitted with systems called IFF, for identification, friend or foe. This projects a coded signal at the other aircraft. This IFF screen in the fighter shows 3 unidentified aircraft. Once the pilot transmits the IFF interrogation signal, the friendly aircraft return a coded signal which is displayed on the screen as blinking symbols. In this case, the 3rd aircraft is an enemy. Even with the most modern IFF systems, there is still an element of uncertainty. Maybe the 3rd fighter on the screen is a friendly fighter with a damaged IFF system. Maybe it is a fighter from an Allied Air Force with a different IFF code. Until IFF systems are made more reliable, many pilots are reluctant to start firing until they have positive visual identification. As the fighters reach visual range of one another, the classic dogfight begins. At 10 miles or so, the enemy fighter has entered the 2nd envelope, the envelope of the heat-seeking missile. The pilot aims through his heads-up display. On World War I fighters, pilots aimed through a simple metal ring and bead sight. By World War II, this was replaced by a simple optical sight. But missiles need a better means of aiming. In the late 1970s, the HUD, or heads-up display, arrived. The HUD is more than a gun sight. It gives the pilot a great deal of other information during the course of a battle. Instead of being distracted by looking at his instruments in the cockpit, the data are in front of him. The symbol in the center of the HUD shows the attitude of the aircraft relative to the ground. The left bar tells the pilot the aircraft's speed, the right bar the altitude. The small box is computer linked to the radar and automatically tracks the enemy fighter. In missile mode, as seen here, the data at the bottom tell the pilot he has 2 missiles armed, he is in range of the enemy plane, and it is 45 seconds until missile impact. In gun mode, the HUD tells the pilot how much ammunition is remaining and where to steer the airplane to hit his target. The HUD is also critical in aiming a heat-seeking missile like the AIM-9 Sidewinder.
As far as the AIM-9, yes, we do get cockpit indications. What we get is a display up on our heads-up display. We basically get a circle indicating where that heat missile is looking, and it mutates, as we call it, sits there and rotates around the aircraft. If we can see the aircraft in our HUD field of view, it's actually tracking them. We also get a tone in our ear. It basically differs between the AIM-9L and the AIM-9M. One is a chirp and the other one is just kind of a tone. But you can tell that there is no doubt in your mind that it is tracking the heat source out there and what heat source it is tracking.
A modern dogfight, even at visual ranges, is a much more complex affair than in the era of the Red Baron. So a major emphasis in the design of new fighters is to simplify the pilot's tasks. The objective is to give the pilot all the necessary information and controls at his fingertips. Besides the HUD, another new major innovation is the HOTAS throttle. The HOTAS places many of the basic flight controls on the control stick, simplifying the pilot's workload.
They've also added a HOTAS function for the F-18, which is hands-on throttle and stick, where virtually all the radar and the instrumentation work can be changed from leaving your hands on the throttles and your hand on the stick, which means you don't have to move your hands around the cockpit much to change anything.
In spite of the technological differences, the modern dogfight has much in common with the classic dogfights of World War I and World War II, once it reaches the visual stage. The essence is much the same. Spot the enemy before he spots you, protect your wingman, maneuver to attack the enemy. Man becomes more important than machine.
I think it's imperative that a fighter pilot have 20/20 or better vision and at least corrected to that. I think it's critical to have excellent eyesight, and not only excellent eyesight for your Mark I eyeball, but also to have a very good visual search pattern as you're flying out there. That's something that we stress in early mission qualification training for young guys coming into the fighter community. It's imperative to be able to find that threat, because no matter what type of radar you have, at any given time, it's only going to give you a tally-ho on one aircraft.
But a World War I dogfight took place at 60 miles an hour. A modern dogfight takes place at nearly 10 times that speed. As fighters became faster, the physical strains on the pilot increased. In a high-speed turn, the pilot is subjected to the crushing force 9 times the Earth's normal gravity, or 9 Gs. These forces can be so great that the pilot can lose consciousness and lose control of his aircraft. Some critics have charged that modern fighter technology has exceeded human capabilities. But fighter pilots look to training rather than technology to solve the problem.
You solve those problems in pilot training. You educate the guys that that this threat exists or this problem area exists, and you teach them how to counter it. And they teach us maneuvers on how to tighten up our bodies and keep the blood from flowing down to the lower extremities or to the outer extremities, out into your arms and down to your feet, so that you don't lose consciousness in the air. And they can put us through a centrifuge at Brooks Air Force Base that teaches us to work on these straining maneuvers that allow us to keep the blood up in the top portion of our bodies. They've also tried things like reclining seats, like an F-16, reclining that back in a 30-degree angle. The F-15 seat is reclined at a 15-degree angle. This is designed to create more of a transverse G component, or a G through this part of the body instead of from top to bottom. And that helps the pilot a little bit. Obviously, the anti-G suit helps the pilot a little bit. For the most part of it, the technology, the things they can do technological-wise, like slanting seats back and things like that, can't begin to have the effect that the individual straining maneuver does, and that has to be taught in pilot training.
The performance of a modern jet fighter is remarkable. So is its price tag. A typical jet fighter today costs $15 to $40 million. In comparison, a World War I fighter would cost about $50,000 and a World War II fighter about $500,000 if purchased today. A modern fighter is about 400 times more expensive than a biplane fighter. This price increase has been brought about both by the increasing size and complexity of fighters. A biplane fighter weighed half a ton, a World War II fighter about 5 tons, and today's fighters up to 25 tons. A modern fighter is 50 times more massive than the delicate biplane fighter of 1918. Since the advent of radars and jet engines in the 1950s, complexity has risen quickly. A modern fighter is a complex weave of airframe, power plant, avionics, radar, and electronic warfare devices. Today's fighters are not much larger than fighters from the 1960s, but their electronics continue to rise in sophistication. Electronics make up over 25% of the fighter plane costs. These high costs are not peculiar to military aircraft. A medium-sized jet airliner costs about $40 million, more than the average fighter plane, and a jumbo jet costs well over $100 million. A typical high-performance jet fighter costs about $20 million these days. Of this cost, about half is due to the basic airframe. Fighter airframes are expensive since they must be able to withstand the harsh conditions of supersonic flight. They must be able to withstand the crushing loads of high-speed turns. The skin of the airplane is subjected to the extremes of freezing temperature of high-altitude flight and the searing heat caused by air friction at lower altitudes. Aluminum has been the main ingredient in fighter plane construction. Today, the recipe is more exotic. Rare metals like titanium and special lightweight alloys are used to give the airframe its needed strength. Some of the new materials are not even metal. Composite materials made of carbon fiber and other minerals are making up an increasing fraction of a fighter's structure. The single most expensive item in a fighter is its jet engine. A typical jet engine costs about $3 million. There are less than half a dozen countries capable of manufacturing fighter engines these days. This is due to the extreme difficulty in manufacturing certain key components, like the turbine blades. These blades must operate at temperatures of several thousand degrees and at very high speeds without disintegrating. The new generation of engines has finally overcome the propulsion barrier. For the first time, their thrust is equal or greater than the weight of the aircraft. This enables the fighter to execute sustained vertical climbs and sustained maneuvers without a significant loss in speed. A fighter with such an engine can easily outmaneuver an older fighter with a less powerful engine. Surprisingly, these engines are also a great deal simpler and more efficient than engines from a decade ago. They are smaller and have fewer working parts. The phenomenal climb and maneuverability of modern fighters is due mainly to these advances in engine technology. The other expensive element of the fighter is its avionics. Avionics is the name given to electronic systems aboard a jet aircraft like the radar, radio, and navigation system. About a quarter of the price of the jet is due to electronics, somewhere between $3 and $10 million. A radar can cost $1 million. And fighter weapons are not cheap. A heat-seeking missile like the Sidewinder costs about $50,000. A long-range radar-guided missile will cost 3 times as much, about $150,000. Fighters are gas guzzlers, particularly when using afterburners at high speed. A typical fighter will consume nearly $1,000 of fuel for every hour in the air. The complexity of a modern fighter demands flawless maintenance. The ground crews spend 25 to 50 man-hours of labor for every hour the fighter is airborne. As a result of their high costs, there are fewer fighters in service today. Where an Air Force might have had thousands of fighters, now it has hundreds. But the fighters are now capable of performances that would have been unthinkable 20 years ago. Pilots have always been a singular breed of soldier, no more so than today. If there is one feature that distinguishes today's fighter pilot from his counterpart 50 years ago, it is training.
We start pilot training with everybody else, the bomber pilots and the MAC pilots and that sort of thing. We start off in pilot training in the T-37, and we progress to the T-38, and at that point we're selected for an assignment, and that's the first time we realize that we're now going to be a fighter pilot. Following graduation from pilot training, we continue on to Holloman Air Force Base into the lead-in fighter training program. It's flying a T-38, it's a modified T-38, and you get an introduction to basic fighter maneuvers there, basic bomb dropping, tactical formation, those sorts of things, basic fighter pilot skills. After that, you're sent to your replacement training unit, RTU. They've called various things for the F-15. We call it the RTU. For about 4.5 months to learn to fly the F-15, and again, a little more advanced course on basic fighter pilot flying, basic fighter maneuvers, ACM, ACT, you probably hear those terms tossed out. Following that, we'll come to our assigned unit, and we'll spend another 3 months becoming mission ready in what's called mission qual training, MQT. And at that point, we're a fully mission ready pilot and ready to do our mission.
Air forces are demanding of their pilot candidates. It will cost over $1 million to train a fighter pilot, and he will be flying a $20 million piece of hardware. To keep his skills sharp, a fighter pilot flies about 200 hours a year. Those 200 hours of flight time cost the Air Force about $700,000. He must be intelligent enough to absorb the technical training he will receive, and athletically prepared to handle the enormous physical demands of maneuvering a fighter at supersonic speeds. He must have superior coordination and eyesight if he hopes to survive in a modern dogfight. This rare combination of skill and training make the modern fighter pilot the elite of today's armed forces.